In this video, we're going to learn a method for simplifying expressions with I to some random power. Now, it turns out we're going to use division and look at the remainders of those division problems to help us simplify these expressions. But before we get to that method, let's look at a pattern when we look at the first few powers of I. So I, that equals the square root of -1. But for the purposes of this investigation, let's just simplify that as I to the first power. Now I squared, well, since I equals the square root of -1, I squared would be I, which is the square root of -1, squared. And anytime we square a square root, we get what we started with, or what's inside the square root sign. So I squared equals -1. I to the third power, well, that would be I squared times I. Well, we know I squared equals -1, so I to the third power equals -1 times I, which is just -I. I to the fourth power, that's the same as I squared times I squared, which equals -1 times -1, which equals +1. Let me rewrite this one up here. So we'll have plain old I here, and this will be I to the first power. Continuing on, let's see, I to the fifth power, that would be I to the fourth power times 1, or times I. Well, I to the fourth power equals 1. So I to the fifth power equals 1 times I, which equals I. Notice that was up here also. I to the sixth power will be I to the fifth power times I. Well, I to the fifth power is I. And then we have another I, so this is I times I, which is I squared. Well, I squared equals -1. So I to the sixth power equals -1, just like I to the second power equaled -1. I to the seventh power, well, that's I to the sixth power times I. I to the sixth power equals -1, so it's -1 times I, or -I. Just like I to the third power equals -I. So we're starting to see this pattern here is repeating itself. So here we start out with I, -1, -I, 1. And we start it over again. I, -1, -I. What will be next year? Let's check. So I to the eighth power, that would, one way to rewrite that would be I to the fourth power times I to the fourth power. I to the fourth power equals 1, so it'd be 1 times 1, which equals 1. Just as you might have been expecting. And we'll do one more here. I to the ninth power would be I to the eighth power times I. Well, I to the eighth power is 1. So 1 times I would be I, and we start all over again. So when we're simplifying an expression with I, like these over here, we really only have 4 possible answers, these right here. So we just need to figure out a method to figure out which one of these answers is the one that we need to save us work of writing these out the long way. We can use division to do that. And here's how. So I to the fifth power, notice the exponent is 5. If we take the exponent, and we're going to divide by 4, always by 4. Let's look at the remainder. 4 goes into 5 once. We multiply and subtract, we get a remainder 1. Let's try it with 6. See if we see a pattern here. 6 divided by 4. Remember, this method relies on us dividing by 4. Because to remember that, we can remember there's 4 different possible answers. 4 goes into 6 once. We multiply, we subtract, get a remainder of 2. Well, notice in both cases here, the remainder matches the exponent of the answer that we want. So I to the fifth power, we divided by 5 by 4 and got a remainder of 1. So it matches the answer for I to the first power, which equals I. Notice I to the fifth power equals I. We divided by 4. We got a remainder of 1. So we knew, without even working it out, that the answer would match up with this first one that went with I to the first. So the remainder matches the exponent of these first 4 expressions of I. With 6, we know the answer is -1 already because we worked it out the long way. But if we take 6 and divide it by 4, we get a remainder of 2. So that tells us it matches the answer for I squared, because we had a remainder of 2 when we divided. So I to the 6th power equals -1. When we divide 7 by 4, we get a remainder of 3. So we know the answer of I to the 7th power equals I to the 3rd power, because the exponent is 3 and matches the remainder, and I to the 3rd power equals -I. So far what we've seen is that when we have a remainder of 1, matches the exponent here, we know the expression simplifies to I. When we have a remainder of 2, matches this exponent here, we know it simplifies to -1. When we have a remainder of 3, notice it matches the exponent here, it equals -I. Well, when we divide by 4, we don't get a remainder of 4, we get a remainder of 0. So when we divide by 4 and get a remainder of 0, we know that the expression simplifies to 1. Let's see how that works here with 8. So 8 divided by 4 equals 2 with a remainder of 0. So I to the 8th power equals I to the 4th power, which equals 1. Let's see how that works with 9. So I have 9. I'm going to divide by 4. Well, 4 goes into 9 twice. We multiply and get 8, and subtract and get a remainder of 1. Since we have a remainder of 1, well, that matches up with the answer for I to the 1st power, so it just equals I. And sure enough, that's what we got earlier. Okay, it's time to try these more difficult ones. So I to the 35th power. Let's take 35, and we're going to divide by 4. 4 goes into 35 8 times. 4 times 8 is 32. We'll subtract, we get a remainder of 3. So a remainder of 3 equals -I. So this will equal -I. I to the 72nd power will divide by 4. Well, 4 goes into 7 once. 1 times 4 is 4. Subtract, get 3, bring down the 2. 4 times 8 is 32. Subtract and get a remainder of 0. We have a remainder of 0, well that equals 1. Finally, we can do problems like this real quickly in our head. 17 divided by 4. Well, 4 goes into 17 4 times, but it has a remainder of 1. Let's see, remainder of 1 is equal to I. Okay, now this method relies upon being able to either remember these expressions or be able to write it out. So when you're faced with a problem like one of these, you just want to make sure you can figure out, or you remember, what each of these equals. So I to the 1st power equals I. So anytime you get a remainder of 1, it equals I when you divide by 4. I squared, well, that's the square root of -1 squared. So that equals -1. I to the 3rd power, well, that's I squared times I. So that would be -I. And I to the 4th power would be I squared times I squared, which is -1 times -1, which equals +1. And this is the pattern that repeats itself over and over again. Okay, I hope this video has been helpful. Signing off.